Hi, welcome to Linux channel. If you are new into product architecture and you are kind of putting together a huge product, then this is a video for you. See, as you build a huge product, you need to have various components, subsystems, and supporting modules in these subsystems and various APIs and flow between these APIs and things like that. One of the important things is you should also get various levels of statistics, and with these statistics or with these metrics you can pull them into a database, get graphs and things like that. But the end objective is we should able to have some sort of control on whatever has been available in open source. Not just like that, even if you have a custom module and it is kind of plugged into an existing kernel source or something you have built on Linux user space, which is also interacting with other open source components and things like that. At times the open source components may lack some kind of metrics and statistics and stuff like that. So in that case you need to extend its capability. It may be just adding some few APIs, extra APIs to that existing source, or it may be just extending some kind of extra variables and then extend its capabilities and stuff. So as a part of that, you can see in my case, long back when I was working in Traffic Squeezer, and then eventually it got morphed into Toffee and the Toffee project. I have also done few things like that, and I have added some few extra variables to that escape of data structure, and which is what I am going to show here. See, I have also added some few APIs, supporting APIs. Along with that, I have also added some few variables as well, because the existing API has several things, but in my case I need some few extra variables in terms of quickly locating its packet pointer offset and things like that, so that instantly I can send it in a wrapper API which does entire computation, and then further I can get these metrics available in that SKB instance. In every SKB instance I do this, and then I get this metrics available which I can further use in my stack. So this is very vital. As I said, you have your components, but at the same time you are relying on other open source dependencies and stuff, then you can do something like this. So you can see here, in my case, you have the escape.h. I have written my own escape.h, where you can see I have added some few APIs. For example, like this Toffee get IP destination IP address and stuff like that. And also this Toffee parse packet. It is a huge API which parses the entire SKB data structure, and it assigns all the necessary pointers, and it does all sorts of necessary checks. So you should understand these things are done already in the IPv4 stack. Most of the cases, as the packet goes via various APIs or various layers. So that is also done, but at the same time it is something somewhere it lacks, hence it is better. I have added in my case myself an API like this. So if you see this API, you can see Toffee parse packet. The source code you should able to find it in somewhere like a net Toffee, and then you can find the skb.c. Okay, so you can see I have done a lot of hash defines. Sometimes you don't need to do that. You can use even existing system defined hash defines. But in my case, I have added this. You can see here various switch case stuff. So ignore this part. You can see the main API which I talked about, which is this parse packet, which is like a big API, and that API will call further small APIs. You can see the static private APIs. So you can see that. So whatever packet comes, I am checking whether it is IPv4. If it is IPv4, do the header length stuff, and if any mismatch, then return errors and stuff like that. The regular parsing stuff. The question is why we are doing this. The reason I am doing this is usually you don't need to do this. If you tap the packet set IPv4 stack, because all these tests are passed. For example, in IP receive API, it already checks checksum and stuff. It already checks whether it's a valid v4 packet or not. You can even go here, which I have talked about these multiple episodes. So you can anyway go here, net IPv4 IP input, IP input.c, and you can go to this last API, which is this IP receive, and IP receive has this internal API, you can see there, called IP receive core. Yeah, this is where it is. So this is the IP receive, and you can see IP receive core. So this API does whatever needed for that IP receive, because in the past there is no API called IP receive core. That's been added by around 4 or 5 years back, so which is around 2019, 2020 or something like that. So there's no API called IP receive. So IP receive core, it's just recently added, and in an attempt to declutter this IP receive so that you have the abstract wrapper API. That wrapper API calls the important functionality of that API, which is being moved away from this wrapper API called IP receive core. So in the IP receive core, if you notice, you have this thing happening. You have this extraction of IP header, and then it will check the checksum whether it is valid. Then it is also tallying up with the total length, and then it is seeing if there is any mismatch. Then it is discarded. So you can see every step it is validating, and if there is any malformated or corrupted IP headers in a packet, it is also discarding it. And well above this, you can also see it's also checking whether it's a valid v4 packet or not. So same thing, something similar I was doing, which is more aligned to my requirement. There is one difference is, in this case, when the kernel is doing this, it's only doing a known IP packet, which is what classified and comes here. There's no question of any v6 or something leaking over here. Yet they are checking whether it's a valid v4 packet or not before going into the upper layers, upper APIs. You can see there, after that it goes to IP receive finish. From there again it comes to IP receive finish core, so on. So before even it goes there, they are doing all these things. But in my case, I need to do certain other objectives, and the main interesting reason why I am doing this is, see, this video has nothing to do this. I'm just giving a case study as an architect, as a senior dev, or as a complete product architect. Even what I work in day-to-day basis, you have to take all this tidbits and then get ideas in terms of getting your product architecture. So hence I am giving this as a case study, but it has nothing to do with this. Okay, just take this as a case study. Hope you can understand and follow what I am trying to say. If you have any confusion, you can be in touch in YouTube comments or whatever, and you can discuss. So we go back to this. You can see there it's been done, but at the same time I am also doing. The reason is the context where I get packets is sometimes I may fork here and I may get known v6 packets. Sometimes I may fork in even Linux bridge. So if I do that, then I may get any bridge frames. It's just not packets, it is the frames, which means SKB, which has layer 2 headers as well. So it may be a bridge, I may fork, then it's an entire frame, means L2 and then IP and things like that. And in my case, I will be extracting v4 alone, so or taking only the v4 packets. So if I do here, it is different. If I do there, it is different. Hence, I am doing that kind of parsing. So you can see there, I am doing this parsing. And one more thing is, I often tell this network parsers and stuff like that. In fact, recently even I have shot a video episode on a network parser components, and moreover I have shot various videos on various components of networking stack and stuff in a much detailed way in different playlists. In case if you are interested, you can request, I can add it in the YouTube comments. So you can go through that. So hence, you can see this is also an example of a packet parser, where the objective of packet parser is to either convert the raw packet into a meaningful data structure so that we can go through quickly those contents, or otherwise in this case it is already in the data structure like SKB, I am further parsing it. Okay, so that's what the intent is. So you can see there I'm doing all these checks. If it is v4, then I'm doing this and I'm getting this header length. So all these things are there. So instead of dereferencing IP of, see for example here IP header I'm getting, and then I'm storing the pointer here, and you can see the SKB I have modified, and you can see config toffee I have added all this extra member variables, you can see there. So this is one thing you can improvise and do something. Again, I'm not advocating this is the only way you should do. I'm just saying you can add the capability of any existing data structure or the combo of data structure and APIs of any existing open source and add your own stuff to accomplish certain necessary things so that it can be now utilized as a part of your product architecture. So in my case, I just want to put it here so that all these things are more readily available. I don't need to do something like how to say, I don't need something like I don't need to dereferencing something like IP of say for instance here they are doing this, do this, here do this, and then dereference for example IPH of what I'm doing here is IPH of IP header size, something like that, IP proto or something, IP header of IP proto each time, something like this. So what I'm doing is I'm keeping those things dedicated in dedicated variables so that I can dereference like this SKB of toffee IP header size, which instantly gives me what is the total IP header size, because IP header length is somewhat tricky. Without options it is 20 bytes. So the standard IP header you can see here. So general IP header is 20 bytes, but if you add any options, then it is going to increase. So in case if it has any options, I need to account them. Hence, I'm keeping all this supporting variables to quickly get that information. There is also a case that sometimes SKB itself internally maintains as an extra metadata. If you come here, here SKB. If you come to the SKB data structure, sometimes they may also time to time add new variables. In case if the variable is added and now it is available in the stock Linux kernel, you can use those variables itself. But in case if you don't have those stock variables, then it is better to deduce like this and just keep it yourself a quick record of this. See for instance, this IP proto is not needed. Okay, toffee of IP proto, which is nothing but SKB of that IP header protocol, because if you see where is that let me go here, you can search for this IP header data structure and you see here they call it as a protocol. So I'm sorry, here it is not IP proto, it is protocol. So this is what you can do, some if condition, something like that. You can use equal to IP proto, TCP, etc. You can use this variable in this way. Rather than doing this, what I'm doing is I need it in single call, or I mean in a single quick dereferencing. I can do directly SKB of toffee and IP whatever I have put the name, IP proto equal to IP proto TCP, something like this I can do. So this is more of a convenience to me, and of course again this is subjective, but along with this the important thing is you can add some kind of metadata. It can be something you need some sort of stats or something like that, or some stats you are counting other than trying to use any MIPS. You are trying to use any custom stats, or you are counting some packet drops for some weird reasons, something like that. You can mark that SKB in this way. Of course there are also other ways to do. Sometimes people tend to use these IP tables and net filters, and they try to mark it in a different way, which I generally don't like that. I like generally writing my own stack on top of the kernel source like this. either in a module form. In this case it is not, as you can see, it is not any external kernel module I have written. I have directly embedded my code directly on that, so it is not done in a module form. So you can see that. So this is one example. Other than that, I need to know also what is the transport what is the port numbers of this transport layer. So you can see here I am also doing this parse L4 header, which means I can accommodate both UDP and TCP. And somewhere you can see here, and that's what I am doing is parse L4 header, and I have to do all this stuff. UDP means do this way and find out eventually what is the what is the transport layer protocol or the port number it is listening. From that we will get an idea of what is the payload it is carrying, the application layer protocol. So if it is UDP, source port is something or destination port is something, say if source port is 80 or destination port is 80, then it may be HTTP, or otherwise it is source port is DNS or destination port is DNS, then it could be DNS packet, something like that. You can see there. And it can be, you can do that for TCP, and the similar way you can do for UDP as well. And you can see here, that's what actually I'm comparing here. And eventually after it is compared and all the things are computed, you can see that I'm just going to populate over here, and that is why I'm adding some extra variables over here, and you can see that. Similarly, I can also have a pointer pointing to SKB data. L2 header, you can see there, L2 header and L2 payload, which means this should point from IP header onwards. The reason I kept as L2 payload is what if it is not an IP header, it is a V6 header. So in that case, it's generally called as L2 payload. Hence, that pointer is going to point at the end of L2 header, which is the start of IP header, or V6 header. That's what it is. Or if not, it can be any L2 slow protocols, it will point over there. Suppose if it is an STP protocol, it is going to point the beginning of that STP protocol right after the Ethernet header or L2 header. So that's what is that. So you can see I have all readily available pointers, and you see even this pointer, you see here, it is going to point at IP payload, which means it is going to point at the start of TCP or UDP or ICMP or SCTP or whatever is the transport layer protocol. You can see there again, this pointer I kept it. After all that parsing, I can just keep a readily available pointer which is going to point at that location. Similarly, you can see here, this is going to be IPv4 header. Hopefully this is the beginning of that v4 header. So that's what it is. And you can see then we also need this IP total length, that is also being kept readily available in these variables. So things like that. So the whole thing is along with that you can see even the source proto and stuff. So the whole idea is if you are building any huge product, see how much you have the dependencies on various external open source modules or open source components, and in case these components are lacking some functionality, try adding some metadata like this. The whole video is about how you can extend and add some metadata as a part of your product architecture. As I always shoot, usually my videos at times is not for beginners. This is for somebody who is very much into the industry, somebody who is an advanced level systems advanced level software developer, or a proper architect, systems or product architect, who is looking out for some snippets and trying to get into that sort of a thing. So I do generally lot of things like that as a part of accommodating the product architecture, because when you work as a developer, I often get students at various age groups. The industry experience wise, someone who is around 2+ years, is just starting in the industry. I don't usually get freshers, someone who is just out of college. Very rare, at times I do get some international students. They are usually college studying students or doing their masters or PhDs and stuff like that. So that is aside. Other than that, I don't get much who are in the industry who is a fresher. I do get often who is around 2 plus, 3 plus, or 5 plus, 10 plus, or even I get students who are around of my age, around 40 plus also. So in case you are transitioning from a senior developer to a complete architect, so what is the difference between this is, when you are a developer, you are still under a manager or some team lead, or you may be the team lead, but you may work in component level. You are not working at the whole system wide stuff. But when you transition as an architect, then you are the main author of the entire product. You have to architect the whole product, so you have the full freedom to do whatever you want and get the entire product to manifest. So this is a different thing altogether. You are no longer like before, where you are working under certain constraints and stuff like that, because you are now the architect. You have the complete freedom how to architect your product or a solution. Hence your mindset should be different versus what it was before. Hence I'm saying, if you are working in as a senior software developer or something like that, you are going to work in some module or some component level, or maybe you may be working on some couple of modules and stuff. But here, as a the whole mindset changes. You are working on a product as a whole. Hence you need to get that bird's eye view of that product architecture, which you are actually doing it by yourself. So hope this video is helpful for people like you. I have done a lot of such videos. Usually my channel is not going to be like viral and stuff like that. Such kind of videos, it is niche. It is hard to find, because I mostly take niche topics which generally not many will cover, and it is only meant for very slim target audience, and I feel little comfortable taking such topics. Of course I do take once in a while broader topics, but I try to restrict like this, so that it tries to connect to people who are working at a different level of situation, which usually won't get people to talk with. Actually, I mean to say, you work at something which quickly you don't find where to ask help, or like-minded people and stuff. So of course you can connect someone randomly at any discussion forums or anything like that, or these days of course you can seek some help to an extent from AI tools and stuff like that, or maybe Stack Overflow, some random person, or Reddit, some random person may help you. But at the same time, you are working at a very niche stuff. To an extent you can get some support, but after that it is just your problem, your job and your headache it is and you cannot openly discuss with others. So hence what I like to do in my channel is, I want to do like this. This year it is also completing a decade after I started this channel. Not exactly, because I started around July, August timeline of 2015. Now it is 2025. So in just few months it's going to complete 10 years of Linux channel. Hence I want to keep it this way, and I feel more fun and connecting people in this way, and because this is what I feel it's niche, and this addressing this niche is more fun rather than taking that regular stuff. So this video will make sense in case you are in that situation. Feel free to experiment, add some capabilities yourself to the existing stack or existing open source components, so that you can extend. I have done various examples. Even I have done something I was talking about, a custom firewall and stuff in my earlier channel as well. Again, the problem with IP tables is you won't get extensive stats and metrics and stuff like that. Any packets dropped, what is the status of that, what type of packets dropped. All these things you cannot get from regular net filter or IP table rules. It's just going to enforce those rules, but again it is not going to keep a track of these metrics. Hence it is again making sense to add your functionality and modules intercepting the kernel stack. Either you can do this way. In this case I'm kind of directly adding an SKB. Sometimes it's just not possible this way. Then you can add your custom modules with custom metrics externally, so that you can route your traffic, parse it, and then store it in that data structure, keep it available separately, and when in need you can able to get that metrics, and then you can sort of plot in charts, get it in a database, or you can even feed these important metrics to any AI engine or AI tools to get further analysis out of your system or a product as a whole. So hope this video is useful and insightful. So if you want to connect or be in touch with me, you can discuss in YouTube comments, or you can post your queries in mail as well. So thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.